everyone. Thank you so much for joining today's webinar. As Michelle said, my name is Karishma Punwani, and I'm here with my colleague Nadia, and together we're going to tag team this webinar and show you a bunch of new features that will be in Maple 2023. So this is your sneak peek. Something to keep in mind, as Rochelle had mentioned, Nadia is going to help me monitor the Q&A portion of this session. So if you have questions, put them in the Q&A. Of course, we will always reserve time at the end of the webinar to answer any questions. And so without further ado, I think we should begin. There's lots that I want to cover. So I'm going to share my screen. And Nadia, are you able to see that?
Yes, all good.
Perfect. Okay, so today we have a jam-packed webinar, and what I want to show you are some of the features that Nadia and I are really excited that will be making an appearance in Maple 2023 when it comes out. So I've organized this webinar into 4 different sections, and we're going to start with some of the improvements and enhancements that we've made for to visualization and the Maple interface. So let me bring up my worksheet. And the first thing I want to start with, and I think this is something that Nadia and I and Samir are really excited with. It comes as a result of feedback from users, and it's to have color bars. So in Maple 2023, plots produced by the density plot command and the contour plot command will now have a color bar by default. And so you can control whether the color part is displayed by using the color bar or color bar option. And so by default, as I said, you will get a color bar. And so let me show you just 2 examples. So here's this first one, and you'll see right away, I didn't have to do anything. I got a color bar, and here's another example. And now when I spoke to Samir a little bit, and we talked about this feature, he was really excited from a pro perspective, from an industry perspective. He often talked to me about examples where in the past, because we didn't have a color bar, he'd sometimes look at a 3D plot, but it was hard to get the information that he wanted to extract the information. And so this makes a lot of applications just easier, and allows people to kind of extract information that they need from the plot. So this is an improvement that both Nadia and I are excited about. Another one, again, something that we've added to the product as a direct result from user feedback. I would say this is a quality of life improvement. And so one of the things we've done is the help system now opens help pages in tabs. So you can have multiple help pages open within the help system. So I'm going to pull up this help page. Of course, it's on my other screen, pulled up the what's new in Maple 2023. I did that on purpose. So there's no way Nadia and I would be able to cover everything that's new in Maple 2023 in one session. So once the product is out, please go ahead and look at what's new. There's also going to be information on our website. But for what I wanted to mention here, you'll see I have tabs. So I'm going to open kind of the what's new for advanced math. I can do one for signal processing. I can do one for programming, so on and so forth. The other really nice thing about this, and I don't know if it's happened to you, in the past, it was sometimes hard to know what the link was, the direct link was to a help page. So you'd have to look for it, and then you try to copy and paste or remember it. Here I could just click on this, copy help topic name to this page, and go ahead and close this. And now I can use it. So I can say something like, here, check out the enhancements to signal processing. And I can easily take this and link it straight to the what's new for the help page. And here we have it. Another thing, so Maple 2023 offers more options both in the context panel and through the right-click menu to change the size of a matrix or a piecewise function. So here I have this matrix. If I right-click on it, you'll see I have options to insert rows, insert columns, delete rows and columns. So I'm just going to go ahead here and actually let me execute this so you can see, and I'll go and I'll insert a column to the right. And let's populate these just with some values. As usual, I can use tab to maneuver within the matrix template. And here I have it. Same thing with piecewise. So here is my piecewise function. I got this out of the palette, just as a reminder. So we do have these palettes over here. So here's the template for piecewise. So here is my matrix, my piecewise function. And now I can go ahead and right click. I could also do it through the context panel over here. And I will, let's say, insert a row. Actually, I wanted it below. And now I can make some changes here. So I'm going to say this is X. And let's change this one to, and we'll put, go ahead, enter, and you'll see that updated. And then the last thing over here is that in Maple 2023, you can actually add custom content to your tasks palette. So I want to show you, this is really important. Let's say you have some kind of math expression or something that you want to reuse multiple times within your document. Instead of having to type it out, you could go ahead and just create this little task for yourself. So actually I had done one over here. It's a demonstration, but I'll show you. So I'm going to take this. I can right click on it and hold on. Let me right click. Here we go. Sorry, in the output. So I can say create task and put my piece size. And then you'll see I have it. And so if I go ahead and, oops, I didn't do the full thing. Let's try that one more time. Of course, this is a live webinar, so I was waiting. I knew something would go wrong. Let's try this one more. Okay, trust me that it works. I'm not able to get it to work today, but that's something else that you could look at it, and Nadia and I will figure it out later on. So those are some of the improvements to visualization and interface that I thought members of the audience would find interesting. At this point, I'm going to pause, and then Nadia, is there anything that you wanted to add or any questions that have come in?
Yeah, I mean, just a small comment on the task item. That is, I promise you, working. It's just the thing. It's something also that is quite useful, especially in industry when you use many times the same equation, the same matrix, the same type of content. You just like create it once, then you save it as a task, and then in a click, you'll be able to reaccess your content. So that I'm not gonna say a time saving, but almost a time saving feature for you in industry.
Thanks, Nadia. So I'm going to move from this, and I'm going to go, the page is already open. So let's go and talk about some of the improvements in Maple 2023 towards our math engine and some performance improvements. So as for those of you who have attended these webinars before, improving our math engine is a priority. Year after year, we want to make sure that our users have up-to-date technology to solve the problems that they're working on. And so here again, I've just picked out a few of the topics that I thought would resonate with the audience. So the first one that I wanted to point out and discuss is the improvements that we've done for integration. So the int command now uses Blake heuristics to look for substitutions to find elementary forms for certain algebraic integrands. And so I always find these examples just really goes to show the improvements that we've made. So this is a column dedicated to Maple 22, and this is what happens in Maple 2023. So in Maple 2022, this example, the default answer comes from the elliptic integration method, and the answer is in terms of elliptic functions, which is quite long. So here I have it. Of course, we can get the same answer result in Maple 2023 by calling the method elliptic. But by default now, the answer that you get in 2023 is much more compact. So here's the result compared to the default result in Maple 2022. Another example. So in Maple 2022, the following integral produced an answer, again, in terms of the elliptic function, and You'll see over here the length of the output exceeds the limit. That's what you would get in Maple 2022. And again, in 2023, we have a very compact result. Another improvement in the world of integration is that the in command now exposes more internal routines for indefinite integration through the method option. So it's now possible to directly call the integration by parts routine, known as parts, and a parallel version of the Riche algorithm, and that option is, or that method is called parallel Riche. So here are two more examples. And you'll see this. So here you'll notice that now I'm using this method parts and method parallel Riche. Another one is, so Maple 2023 has, we've added a Z polyhedral sets subpackage to the polyhedral sets package. And what this does is it allows you, so a Z polyhedral set is the intersection of a polyhedral set with an integer lattice. And I think you can see this. So here I have defined a three-dimensional polyhedral set. And now I'm going to call this, and I'm going to create a plot. And here we have it. So simplify. Simplify is used throughout the Maple library. We're constantly making improvements because the improvements we made to simplify you'll see those in other parts of the Maple engine. So one of the things I wanted to share are improvements that we've made to the core algorithm improvements. So Simplify is now more careful about when to reject intermediate simplifications. So here we have it. It avoids normalizing pure rational polynomials when there's no advantage in doing so, or when the benefits are outweighed by the drawbacks. So here, and I'll show you this, in Maple 2022, this used to produce by default, when you called simplify, you would get this result over here. So it has 307 terms. In Maple 2023, now when you call simplify, you get this. There's no advantage to expanding this. And so Maple will just return what is the simpler expression. Now, of course, if you wanted to get back the previous solution, in this case, like I showed you, you could just use normal or factor and you would get that. But this is an improvement we've made to simplify. Simplify is actually better at factoring out common factors out of sub-expressions of type addition. So here we have it. So this expression can now be reduced to 0 by calling simplify once instead of 3 times. We've made improvements to some int limit products. So simplify now follows the semantics of sum in applying limit instead of eval when simplifying sums at a singular point. It also now pulls out non-zero factors from potentially infinite sums, integrals, limits, and products. Trig, I'm just going to run all of these over here. So it now looks more carefully for terms in trig arguments, which are integer multiples of pi over 2, and therefore can be removed, resulting in simplification. So here we have it. Something else is that it makes use of all 6 standard trig functions to express the answer in a more compact form. So in these 2 cases, you'll see. It will convert cos squared x to 1 over sine squared x if it helps. So here's the result. And this is an example that combines kind of the above new features. And here, this is much more compact answer to what we got before in this example. The other thing I wanted to show is an improvement. So now moving on to some performance improvements. So the import vector command can be used to load data from a variety of different file formats. And in Maple 2023, this completes in about half the time. So I ran the import vector command in Maple 2022. You hear the screenshot. It was a very simple file, but you'll see that took about a little over 3 seconds. And in Maple 2023, I'm doing it, I'm evaluating it. It takes about 1.7, so almost half. Now, of course, this is a lot more visible when your CSV file has a lot of data. Something else that I wanted to talk about in terms of performance improvements over here is that the underlying engine that uses to solve a system of linear equations with rational coefficients has been improved for many types of systems. So we recently added, or I should say the recently added solve tools linear solvers rational dense command is now used for most systems of equations with more than 5% of their coefficients are non-zero, or that are also, overdetermined or highly underdetermined. So here's an example of a highly overdetermined system with many solutions, and the new method performs much better. So I'll show you this. So the old method, when I run it, here's some of the, you can see how much time it takes, and here's the new method. And the last performance improvement that I wanted to share, there are a few more, and I'll let you kind of digest that in the what's new, is speed ups for hardware floating point evaluation of numeric matrices. So when initializing hardware float matrix, vector, and array data structures, the kernel will opt for computing with numeric implementations of the initializer when possible. And as a result, you get a dramatic speed up. So here, this example used to take several seconds, and now it returns instantly. So I'll show you right away. And here's a second example. So in this particular example is 2 times faster in Maple 2023. I feel like I went through that very, very quickly. So I'm going to pause here. Nadia, anything you wanted to add? Did I miss something or any questions?
We don't have any question on the chat on that topic, but just a reminder. So Karishma went quite fast, as she said, but this is just a sneak peek of what we've been improving in the advancement section. So once again, we wanted to show you what we thought would be the most useful for you, but there is much more, and I'm sure you'll find something that will fit with your use of Maple.
Okay, so then at this point, let me close this. I'm going to move into signal processing improvements that we've made to the thermophysical data package in units. So let's dive in. So the signal processing package has been expanded with new and updated commands. And so the first one that I want to talk about is the new signal processing Savitsky-Golay filter. And apologies if I pronounce that incorrectly. If Samir was here, he would be able to correct me, but I found this really interesting. So that's why I picked this application. So the command applies this filter to a signal, and the application, what it does is it includes smoothing out noisy data and estimating derivatives of data. And so the filter is also known as polynomial smoothing, least square smoothing, and locally weighted scatter plot smoothing, so LOES. And so the filter works by applying polynomial fitting to a succession of frames, windows containing a fixed number of points. So let's again see this example. So consider the following. So we're going to load the signal processing package. And so now I'm going to have this as my algebraic expression, which I'm going to use to generate the discrete signal. And here, I'm going to specify my start and end times for the signal. So t is equal to 0 to 2 pi. And the number of points we're going to use is 200. And you know what? I realized that over here, let me show you, it's much more interesting if I don't have the output. So I'm going to remove the output. Let's try that again. So here's that function over here. So here's my algebraic expression that we're going to use to generate the discrete signal, start and end times. And here we have is the number of points used in the discrete signal. And now I'm going to use the generate signal command in the signal processing package to go ahead and generate the signal. So this is the times, and here's your signal. And now we will apply the filter. So we're going to have an unweighted and weighted one. So D is the degree of the polynomial used for filtering. R in this case, so this is for the unweighted, is going to be the radius of the frame used for filtering. And now we're going to apply this filter, and I've asked it to output a plot. So here we have it. So you see it does a really good job at kind of smoothing out the noise over here and gives you a good estimate of the filtered signal. And now if we want to go to and see a weighted result over here, I can have my list of positive real valued weights for least square fitting. And I'm going to use the command again. And here we have it. And so, you know, the smoothing, both the weighted and unweighted, as you can see here, significantly reduces the noise, and it's noticeable. So that's the first example I wanted to show. Signal processing is not my area of expertise, but I found this very, very interesting. So I wanted to share this with you. The other application in signal processing that both Nadia and I found interesting was that updates to the signal processing FFT, so fast Fourier transform, and the inverse fast Fourier transform commands. And they now support padding and truncation. And padding is helpful due to the increases in both the speed of the computation and the frequency resolution. And so there's a size option, and it accepts a positive integer and allows you to kind of determine how much padding you want. So this was best. Samir created this, so kudos to Samir, is this application, which I really found interesting. So I'm going to pull this up. And I'm going to walk you through this particular application. So the introduction, as I mentioned over here, you can use a discrete Fourier transform to identify the amplitude of a sinusoidal signal. So that's something we know. Given a signal with n samples and a sample rate of, f of s, the frequency of the spacing, the discrete Fourier transform is the frequency all over n. And an amplitude at that frequency that falls in a DFT bin can be accurately estimated. Okay, that's good. But the question is, what if a signal frequency falls between bins? So how do you figure that out? And so this is where the changes we've made to Maple 2023 really shine. One of the possible solutions to better estimate amplitude is zero padding in the time domain signal. And if you zero pad the signal, the value of n increases, and the frequency spacing of the discrete Fourier transform decreases. And so, for example, if you double the time domain signal with zero padding, the frequency spacing decreases by a factor of 2. So I'm going to just walk you through this example, and we can see. So over here, I'm going to load the signal processing package. These are my number of points and my sample rate. These are the frequencies and amplitudes, and we're going to try to estimate these with the discrete Fourier transform. So here you have it. So these are my 3 frequencies, amplitudes, and this is the power, the time and signal vector, okay? And this is the plot. So here we have a plot of our signal. And now, as I mentioned before, we're going to use the discrete Fourier transform to measure the amplitude and the frequency. So here I'm going to go ahead and I'll do this, evaluate this. So here we have it over here, and something that I want to point out now that we've done this is over here, the frequency and corresponding altitude, amplitudes, I should say, can be obtained by this find peak points command. And if I do that, I'm able to see that we've correctly identified the frequency at 450 hertz. So this frequency we're able to identify using the DFT. So it's 4, and that's, if you'll recall, what we defined above. However, the other 2 frequencies, at 200 and at 800, the amplitudes are not accurately identified, and it's because their frequencies are halfway between the adjacent DFT bins. So what we're going to do right now is we're going to zero pad the signal with a discrete Fourier transform. So here I'm going to pad the signal with zeros to double its length. Now I'm going to convert it to the frequency domain, multiply all the frequencies by 2. And if I've done this correctly, here we have it. I'm going to use the find peak points, and that did not let me. I know this works, so I'm just going to execute all of it. I must have not outputted something. But if I do that over here, you'll see that now I'm able to correctly identify the amplitude at the different frequencies. And if I actually overlay the amplitude periodogram for the original and zero padded signal and zoom in on that point, so we're going to zoom in over here at this frequency, you'll see this particular result. And so something that I wanted you to notice is that right now, with the zero padding, we're actually better able to match the frequencies and amplitudes used to generate the signal. So again, this is not my area of expertise, but I did find this to be a very interesting application. If you do have questions, please feel free to send them to myself or Nadia. And if we don't have the answer, we will forward it on to Samir, who can respond to you. So that's what I wanted to share in signal processing. That's that particular application. And now I wanted to talk about some of the improvements we've made to the thermophysical data package. So what we've done for this in Maple 2023 is the thermophysical data CoolProp sub-package has been updated to CoolProp 6.4.1. And this introduces the IAPWS IF97 water and steam properties. So these are faster to compute than those given previously. And this is at the expense, according to Samir, slightly less accuracy and applicability over a small envelope of temperatures and pressures. So here I just want to show you a few examples. So over here, this is my first example over here. Oops. Go back. And now over here, I can evaluate the specific heat capacity of water n times using this. And there we have the result. So let's talk about units, faster units. So the units package, and in particular unit simple subpackage, have been upgraded to make them faster and several orders of magnitude faster. And so here's an example. So this command has been re-implemented, as I said, to be much faster. And in user submitted worksheets that heavily use units, we often see speed ups between 3 times and 100 times for the whole worksheet. So here's a particular example. I'm going to execute it. So the following example shows a simple forward Euler discretization of constant acceleration for 2 seconds in 200 steps. So here's my procedure. Let's go ahead. And now the test dimensions commands without further options verifies that they're dimensionally consistent set of equations. And then we can go ahead and it computes the dimension. And so this particular example is 200 times faster in Maple 2023 than it was before. Here's another example over here. The following example computes a numerical approximation to pi using a Monte Carlo method. So I'll execute this over here. And this one completed for me in 3 seconds. On some other machines that we tested it, the example completed in 7 seconds, compared to more than 60 seconds in prior versions of Maple. So that's another performance or improvement, I should say, to units. Again, at this point, I'm going to pause. Nadia, anything I've missed or anything that you want to elaborate, or are there questions?
So we don't have any questions. I'm going to assume that you are doing a really good job, Karishma, at explaining that.
I hope so. I'm trying my best.
Yeah. No, I don't have any more comment. And once again, I just repeat myself, but what Karishma is showing is just a sneak peek. So just so you know, there will be more actually in the actual what's new in 2023 for signal processing.
Great. So I'm going to move on then to the last section, talk about some of the updates we've made in 2023 to programming and connectivity. So one thing over here is that an improvement in Maple 2023 is the ability to actually open up MPL files directly in Maples using file open. So if you'll recall, if you have been, if you've authored any MPL files in the past, in Maple 2022, when you went to file open, it would open it, but it would just appear kind of in a worksheet. So here's the procedure. Now, when I do file open, so I'll do that over here. I'll show you an example. Same example over here. you'll see it opens it up in this code edit area. And so now I have the ability to have some diagnostics, a little bit of a debugger. It gives me a sense of, if I've made any mistakes. So this is something I can do. I can go ahead and execute this code. And then something that I want to do is we're going to go in and we're actually going to read that in. So let's go ahead and do that. Oh, my computer's being, there we go. Okay, so I'm just going to go ahead and change my directory. And now if I add my code edit region, we can go and read this in. So here, just to give you an example, I should have told you what this is. It's a little module that we've created. And basically it has two procedures. One is to compute a times x plus y. The other one is square minus 1. Just really for demonstration purposes. Of course, I'm sure most of our users on this call probably have more extensive modules and libraries. But I just wanted to give you a simple example. I'm going to go ahead and read this in. Done that. So here we have it. It has my module. And now I can go and load this. And if I want, so let's go ahead and compute, let's call that procedure AXPY, which computes a times x plus y. Just put some values in. We can do the same thing for square minus 1. So, and if I run this, you'll see the results over here. So that's one improvement. And I think one of the things that Nadia, Samir, and I are planning to do for subsequent releases of Maple is just continue to make improvements to this experience. So this was kind of step one on the journey. I've noticed, and people that we've demoed it to have liked this improvement. Would love your feedback. And there's other improvements that we've made to the code edit region. So if you'll recall, I have a code edit region and it allows you to write Maple commands, functions, and procedures and view them in your document with, their benefits are syntax highlighting, which makes your code more readable. You can, hide the code if you don't want your reader to be distracted by it. And it allows you to indent. There's a lot of features when it comes to programming in Maple that the code edit region offers in comparison to coding within the document or worksheet. So here, one of the improvements that we've made to the code edit region is just, you'll notice over here we have this palette. And so now adding 1D math expressions using the palette is possible. So here, let's say I want to create a piecewise. And that's not where I want it. Let me put my cursor in the right spot. Here, right away, I have it. So now it's really easy to take advantage of these palettes if you don't know what the syntax is or the 1D syntax is. And now I can make changes to this. And let's see over here. Enter. So here we have our piecewise. Adding units from the units palette. So let's say I did 2 and I wanted feet. I can now do that, and I can actually have a hotkey in the code edit region for entering units. So I can say, and it is Control-Shift-U, and I can feet, and that's another way to work with it. And the last thing that I wanted to talk about a little bit is the code edit region now has support. You can now select Python as a language in the code edit region, and the code will be executing using the Python 3 engine, which is distributed with Maple. I didn't have it here, but in the What's New, we talk about all the improvements that we've made and the connectivity, the connection, I should say, with Maple and Python, but this is something I thought was really nice. So you'll go to the component properties. I can change my language to Python. And if I execute this, over here, it evaluates, and this is just, again, a simple Python procedure that will return the identity matrix. And now I can show you how this works. I'm just going to create a function, and I'm going to convert. Oops. Variable. And so this is my Python function. If I've entered this correctly. Oh, I made a mistake. Hold on. Let me copy this in because I probably made a typing error. That's my error. There we have it. And I can go ahead over here and say, evaluate this, and I should have a identity matrix, 5x5 identity matrix. So again, I didn't want to spend too much time on this area, but I did think it was something, an improvement. And since we were talking about coded regions, I wanted to let everybody know about it. I feel like I've whizzed through this presentation. Of course, you know, Nadia, before we move on to the formal Q&A session, anything you wanted to add here?
Yeah, actually, just a comment on the two items that Karishma just presented. So really, the idea that we had when we developed those, I mean, the main feature that is the opening your .mpl file within Maple is to make your workflow, I would say, easier, because as Karishma mentioned, a lot of people who are doing a lot of programming, they prefer to use specific text editor. So she mentioned Notepad++, but I'm sure that some of you have your favorite one. And what we wanted to do here is to allow you to open your file and use, because as Karishma showed it, when you open your .mpl file, you then end up in a code edit region. So you have a lot of feature, like, I mean, you have access to the debugger feature that are built into the code edit region. You can see actually your error. You have also syntax highlighting, the matching brackets. So really give you a tool to allow you in just a click to open your code and check that everything is working, import it, save it, without having to do all those copy paste that can be a bit tedious. So that's really the idea behind this feature, and a bit the same for the Python. Actually, connectivity is like if you have, I don't know, a few lines of Python code because you love coding in Python, we really didn't want you to stop the user actually to use Maple because of that. So it's just giving, once again, a little help for you to getting started and to use Maple actually for coding and for programming, really in a few clicks, and help you that way. That was my comment.
Yeah, thank you, Nadia. So at this point, one thing I just wanted to show you over here, I'm sure you've all seen this. So if you do decide to upgrade to Maple 2023 before March 31st, keep in mind that there is 20% off. And of course, over here, some of the highlights, I tried to cover most of them today. If there's, again, anything specific you want to know about, let myself or Nadia know. If we don't have the answer, we will forward it to the right person who can walk you through this and talk to you about your specific application. So at this point, are there any questions? And Nadia, I know you've been monitoring, excuse me, the Q&A.
Yeah, so just as background info, a lot of people asked about the price for the upgrade. How do I access 2023? Because I think that a lot of people are getting excited to access 2023. So if you'd like to upgrade your license, personal, your company license, don't hesitate to contact our sales team. So either you have the contact of the sales rep in your region, or just email info@maplesoft.com and they'll be happy to help you to upgrade your license. Then we have a question. So someone is asking the same question. Karishma, I'm gonna let you answer. When 2023 will be released?
Yeah, so Maple 2023, Nadia and I are hoping it'll be released within the next few weeks. We're really excited, you know, fingers crossed. It could be as soon as next week. I can't guarantee, but it is imminent. And so you should have it soon. We're really excited about it. It's very close.
Thanks. So someone is also asking, are Python program as fast as Maple code? Is there a difference? I'm not sure the question, like if you mean the same code, is it faster in Maple than in Python? Or, I mean, I would say my answer is really simple, is, well, now that you can import your Python code in Maple, feel free to test it. So you'll be able to test it, but don't hesitate. Once again, if you have like some specific example you'd like us to test or you are stuck, just email, once again, info@maplesoft.com, and we'd be happy to help and work with you. Yeah, so once again, there are more questions about the cost of upgrading and accessing 2023. So don't hesitate to email sales or info@maplesoft.com. So they'll be able to give you a price information.
Yeah. Great. It looks like we have responded to all the questions. I think if there are no more questions at this time, Nadia and I will wrap up the webinar and give everybody an extra 20 minutes back. If there's something else that you'd like to know, want more information, as Nadia had mentioned, please feel free to email us at info@maplesoft.com, and we'd be happy to connect with you and find an answer to your question. So on that note, thank you so much for joining this webinar. I hope you are as excited as Nadia and I on what's coming in Maple 2023, and we'll be in touch. Have a wonderful rest of your day. Thanks, everyone. Bye-bye.